Hey folks, in this video we're looking at how to do weighted averages. Forgot to make a joke, whoops. Anyway, I want you to be able to explain how a weighted average is different from taking a standard average, and then I'd like you to be able to perform calculating weighted averages, and I want to look at some more cool words. So new vocab is really just weighted average, and let's get rolling. So a weighted average, here's a definition from Google. It is based on an average resulting from the multiplication of each component by a factor reflecting its importance. And so really this part is what is different from a regular average. There is a factor reflecting the importance of each of the things we're averaging out. So for example, if we're going to find the weighted average for a mass, the weighted average mass for a group of cats. So we have a group of cats and we want to find out what the average mass is weighted. So what we're going to do is look at this. And so each component, using this language, we're going to multiply each component by some sort of factor reflecting its importance. Well, each component would be the masses of those different cats. And then a factor reflecting its importance would be a percent. And so each different mass is going to get a percent. And that percent is going to relate to us how many of the cats in that whole group have a specific mass. This seems a little bit weird, so let's look at an actual problem with it and do some numbers. So let's say we've got 10 cats. And one of the cats is really, really chunky and likes to eat all the food and weighs 10 kilograms, has a mass of 10 kilograms. The other 9 cats have masses of 5 kilograms each because they don't get to eat as much food. Well, what is the average weight of the cats? Why don't you pause the video and think about it? Surprise! If you said 7.5, that is not the right answer. Now, if we were doing a regular average, we would just take our 10 kilograms and our 5 kilograms, add those together, and divide by 2. But this is a weighted average, and we have to acknowledge that only one of our 10 cats weighs 5 kilograms, while 9 of the cats weigh 5 kilograms. So how are we going to do that? Well, we're going to get a percentage that goes with each of our masses. So we know that the fat cat makes up 10%, 1 out of 10, of that group. And we know the skinny cats make up 90% of that group. So now with this data in hand, this nice little table, we can go ahead and get a weighted average. Let's do that on our next slide. So how are we going to actually calculate the weighted average? Well, we're going to multiply each component by that corresponding percent in decimal form. We have to convert the percentage to a decimal. And so what that is going to give us is what I like to call the weight of each component. And so what we'll do in this specific problem is we're going to multiply the mass of each type of cat by the corresponding percent in decimal form. So here's our table, and I know that, okay, my mass, this is the component, I'm going to multiply that by its weighted, or rather its corresponding percent, but in decimal form. So I'll start with my fat cat, and I'll say, all right, 10% is the same thing as 0.1. I'll do 10 kilograms times 0.1, and I'll do the same thing for my skinny cats. I know skinny cats have a mass of 5 kilograms, and their importance in this is they're 90% of the group. So I can multiply those together. And now I have the weight of each component. And so I'm just going to add these values together, add together the weight of each component to get that weighted average. So I'll do the 1 kilogram plus the 4.5 kilograms. And this tells me the average weight of my cats is actually 5.5 kilograms. It is not 7.5 kilograms because these little skinny cats make up a lot of the group. Nifty. Well, let's try the same stuff but applied to some chemistry. So here we're going to look at the atomic mass of hydrogen. And so normally when we calculate these atomic masses that are found on the periodic table, we're going to look at all of the different isotopes there are for that particular element, and we'll do a weighted average to figure out the atomic mass that goes on the periodic table. So same plan here. I'm going to look at these things. Okay, I'm looking at masses. I want to get the average mass, so we'll be using our masses. And for each one of these, we have a percentage that tells us how much of the hydrogen out there has these particular masses. So we'll follow the same game plan as with that fat cat, skinny cat problem. Sounds like my cat's freaking out. So the first thing I'm going to do is I'm going to convert these percentages into decimal form. So if you don't recall how to do that, the easiest way is to scoot your decimal place 2 spaces over to the left. So boop, boop, just like that, 1 spot, 2 spot. And now we can rewrite this in a decimal form. And if you have 100%, that should just be 1. So if you have like 90%, it should be very close to 1, like this guy. So I will do that for, oh, you know what? If you were thinking this is the way to do this problem, that would not be right. This is a regular average where we take each of the values and we add them together. and then just divide by how many things we added up, but that's not what we're doing here. We're going to be using our percentages. So I've converted this one into decimal form. I can convert my 0.015% into decimal form. And as it turns out, this term is not going to really matter. This guy is negligible, so I'm just going to put in a 0 for that. So I can do all the maths, and very little has changed here. Now this guy is 0.0076 instead of 78. When I add it up, there's very little change in the atomic mass. But we can see actually that the small contribution from this heavier hydrogen, this hydrogen 2, actually makes it so our average atomic mass is a little bit greater than just the mass of hydrogen 1. So very trivial there, because really almost all of the hydrogen is this guy. Let's look at oh my gosh, look at those cute little ground owls. Did you know that some owls live in caves or little tunnels in the ground? That's so cute. And these guys are silly little ground owls, and they make very silly expressions, and I hope you enjoy them. So let's look at this problem where we're going to calculate the atomic mass of lead. And it's very similar to the previous problems we've tried. Why don't you pause the video now and give it a shot and see if you can follow the same process we've done in the other problems and solve for the average atomic mass of lead. Pause the video, try it now. Sweet, you done paused the video and tried that out? Well, let's go through it together. The first thing I'm going to do here is change all of these percentages into percents in decimal form, because that's how I want to use them. So here they are listed out here very beautifully. You can see for each one of these, I moved my decimal point 2 spaces over. So now it's in front of that 5, or now it's in front of that 2, or now there's 0 in front of that 1, and decimal point there. So the next thing I'm going to do is I'm going to take each of these masses. We want to get the average weighted atomic mass, so we'll need to use our masses and their abundances, and I'm going to multiply each mass by its abundance in decimal form. And so I've got that set up down here, and you can already see the results for each of these. I have calculated, and so the last thing I'll do is I will add together these weights that go with each one of the isotopes. So we add all those up, and it comes out to a fabulous 207.2. And if we look at lead from the periodic table, well, that is correct. 207.2 is the average atomic mass that we would expect. So that worked out super hot sauce. I hope you came up with that answer as well. Let's try one more problem. And why don't you pause the video and try this one again? You know, it says average mass of chlorine up there, but that's a lie. We're studying neodymium. So pause the video and see if you can calculate the average atomic mass of neodymium. Go ahead. Okay, sick. You pause the video and tried it out. Well, let's go through together, and we'll follow the same process that we did with lead. First thing I want to do is change all of these percent relative abundance values. That basically says how much of the neodymium out in the world is this guy. Oh, 9.9% of the neodymium we'll find is neodymium-308. Cool. So I'll convert each of those into their decimal forms, and then I will multiply each one of those decimal forms by its corresponding mass. And then I will solve for those to give the weight for each one of these isotopes, and then I'll add it all up to get my final average mass. Sick! Well, that is the end of this video. I hope you feel like you understand a little bit more about how isotopes have different masses and why those masses actually matter when we're determining the mass of an element on the periodic table. And I hope you feel like you can take a weighted average now and understand a little bit more about math. Sick. That's the end of the video. Ta-ta, and have a great rest of your life.